Now that my shop is additive enabled, every problem I encounter has at least one additional potential solution available to me. So when these mower guards started to break on my mower, I knew that 3D printing was an option, but it was a terrible option. These things are huge. Plus, parts are still available from the OEM. They're like $35. I got to pay for some shipping, but it's fine. So I went and bought some new ones, thinking this is definitely the best way to go, and I started to break those too. Now keep in mind, I'm probably abusing this mower. I'm running over rocks and stumps. I really need to be more careful with it, but I seem to always get in a hurry, and anytime I bend a blade or break a weld, it seems to shake these guards off, and then I'm going to have to replace them. So that's my challenge. It's time to put my engineering hat on and see if I can come up with a better solution than what the manufacturer did. So my first thought was just to try to glue the tabs back on, but we all know that's not going to work. This is a weak point in the design, and the glue joint is going to be the weak location in the design, so it's going to fail much faster than the original. This design was designed perfectly for an injection molding process where you want everything to be constant thickness. But what I'd like to do is create a thicker tab or a thicker transition from the mounting location to the housing to give myself more stability. So my plan is I'm going to 3D print tabs to replace these, but these tabs are going to be redesigned. They're going to take into account the weak area and strengthen it by thickening the material. It's also going to create a nice wide area for me to add glue so that I can get a really nice tight bond between these two parts, both moving the joint away from the point of failure and eliminating the weakest point in the design at the same time. Now, gluing these onyx parts actually does a really great job. It's as strong or stronger than the surrounding material, so I'll show you how I did it. The first thing I did is I trimmed away any leftover material that was from those tabs where they broke off, and then I used a solvent to prepare the surface on the part and the new tab. You can use acetone or mineral spirits here. They'll both work. They won't damage the part. Next, I wanted to create a bit of a jig, so I sketched the outline of the part using either the new piece or the broken pieces all kind of reassembled, and put in some nails as pins to help me locate those bosses for glue up. This is a 2-part epoxy. I'll put a link in the description, but this is just a product recommendation straight from Markforged. Using this dispenser gun and these mixing tips, it really simplifies the process of using the 2-part epoxy. I just glob it on, set everything in place, and make sure it's going to stay while it cures for the next 20 minutes. Each of these tabs costs about $7 to print. So when you add in my time as well as the cost of the glue, I may be saving a little bit of money, but certainly not much. And so it's definitely not a situation where I'm trying to save money on the cost of the guard. But what this does allow me to do is eliminate a design weakness in this product. So I don't think this is a manufacturer flaw. However, it is something that's causing me downtime. And so by investing just a little bit of time, I can now start going through and upgrading my fleet with these tabs to make them bulletproof when it comes to vibrations. Just keep in mind, additive may or may not be the solution for you, but if you apply some creativity, you might find that you can solve more problems than you ever expected you could.